Okay, we're good.
Okay, so welcome back. I'm terribly sorry about last week, although very happy to hear things went well with Gavin, talking about the last set of readings, that is, the reading for last week. I had some kind of connection problem, and I'm not quite sure. I changed so many things that I'm not sure which one brought it back. But anyways, we are back. I'm good. And we will continue the course with Gavin and I having a discussion about the material assigned for that week. But thank you again to Gavin for picking up the slack when I could not figure out how to get online. Yep. So, actually, the truth is we were online, but it kept cutting us off, and it was becoming infuriating, right? Me and you talking about the material, and it just kept stopping.
Right.
Anyways, I'm sure that students can sympathize, given that we're all struggling with the online situation. Okay, a couple of things. Today we will talk about the final chapter from Dawkins's The Blind Watchmaker. The title of this chapter is Doomed Rivals. And we'll get to it in a minute, because I want to make a few other comments, and I want a couple of other announcements. But in short, this chapter addresses the purported alternatives to Darwinism. That is, the purported alternatives to evolution by natural selection as the explanation for complex design.
Yep.
Okay, so we're going to talk then about the last chapter, which addresses doomed rivals. That is, apparent rivals to Darwin's theory of evolution by natural selection that really weren't or aren't rivals. And that's how we'll close out Dawkins's book. Now, a couple of announcements. Your reaction papers and submitting your discussion questions and responding to at least 2 other students' discussion questions this week, instead of being due Saturday at 9 a.m., because of the fall break, which is Friday and Saturday, your materials will all be due Monday by 9 a.m. Okay, so your discussion questions, your responses to at least 2 other students' discussion questions, and your reaction paper will be due at 9 a.m. on Monday instead of 9 a.m. on Saturday. So basically, you have 2 additional days to submit your materials. Do you want to add anything to that, Gavin?
Nope.
Okay. So do you usually close the submission portal, Gavin, after 9 a.m.?
Yep. When it's due is when it closes, typically. So.
Okay. So you've altered the due date then for this upcoming assignments?
I've not uploaded those, but by the time this video is up on YouTube, the assignments will be up and they'll be due and closed Monday at 9 a.m.
Fine. Great. Thank you.
Yep.
Okay. And this week then, in terms of the assigned or additional videos, we actually are assigning just one. This is from the PBS Evolution series. This is part 5 for this week, the title of which is Why Sex? That is, why and how did sex evolve? That is, sexual reproduction. As you will learn, or as you've sort of, as I think Dawkins has discussed at various points, at least in passing, that many organisms reproduce asexually. That is, they clone themselves, in short. We don't. Most other species don't. Sexual reproduction is quite common, and given that there are very important costs associated with sexual reproduction, namely, first of which is that you're passing on only half your genes rather than all of your genes. When you reproduce asexually, you're passing on 100% of your genes. When you reproduce sexually, you're passing on just half of your genes because, of course, you're combining them with an individual of the other sex. In addition, you've got to find a mate, you've got to attract a mate. Once you have a mate, if it's a mateship that's intended, that it's likely to be a longer-term mateship, well, then you've got to retain a mate. If it's a bad mate, you've got to jettison a bad mate. All of these are costs associated with mating that aren't part of asexual reproduction. So the question is, why in the world did sex evolve? One of the leading explanations, which you'll learn about in this video, is sex evolved as an adaptation to solve the adaptive problem of parasitic infection. Parasites and hosts co-evolve. So as we evolve defenses against parasites, well, they evolve means of thwarting or getting around those defenses. The problem for us as sexually reproducing animals is that parasites reproduce far more rapidly. And so we are constantly attempting to play catch up. The benefit of sexual reproduction, is that it scrambles up the genetics of offspring. It produces offspring, it results in offspring that are unique with respect to the pathogenic environment. So pathogens have to start over, basically, to infect and to inhabit host offspring. That's a long-winded way of saying it's a very interesting video, and I hope you guys will enjoy it. It's the final video we will see in the PBS Evolution series, and that is for this week. Now, starting next week, we will be beginning our second and final book for this class, the title of which is The Goodness Paradox. I'm looking at the side of the book here. The subtitle is The Strange Relationship Between Virtue and Violence in Human Evolution, by Richard Wrangham. Richard Wrangham is an evolutionary primatologist. He also is, a first-rate biologist, and I would argue he's, also very thoughtful about evolutionary psychology, and certainly a world-renowned expert in animal behavior more generally. And he is going to, basically what we'll do is we'll be narrowing our focus from evolution by natural selection cast broadly across all of animal behavior, and we'll be focusing on, for the most part, focusing on non-human primate and human psychology and behavior, with a focus even more specifically on violence and virtue, or violence and aggression on the one hand, and cooperation and virtue, for lack of a better word, on the other hand. So we'll start that next week, and we will discuss, our first section is to discuss the preface, a very brief preface, sort of explaining why he wrote the book, an introduction, and the first 2 chapters. Okay, and so that will carry us through the end of the course. Next week will be week 8, and the course continues on through week 14. So we are now halfway through the course. Okay. All right. Now, Gavin, how are the discussion questions and responses and reaction papers still coming along in good form?
Yes, they are.
Excellent. I mean, my sense, at least just from taking a peek at some of the discussion questions, some of the responses, is that the students are doing exactly what we asked you to do, just to think a little bit more deeply about the material. Okay, you don't have to generate some grand field-changing set of discussion questions. That's not the point. The point is to simply stay engaged. I mean, it's really easy to let things slip by when you're taking more than one class. Okay, which I presume many of you are, and maybe when you're working part-time or even full-time or have families. Bottom line is, these are all mechanisms, the discussion questions, the responses, the reaction papers, to keep you engaged. Because our experience is students who do well, that is students who get an A in the course, are students who are engaged. They're not the students necessarily who have, an expert handle on the material. Okay, they're the students that stay engaged and turn things in. Okay, I think something like 75% of your grade, right, is basically turning stuff in when it's due. Okay, your reaction papers, your discussion questions, your responses to discussion questions, and that is by design. That is to incentivize continued engagement and involvement. And incidentally, you will accidentally, get a really good understanding of animal behavior as a consequence.
Right.
Okay, so let's talk briefly then about this chapter 11, the final chapter. Unless there's anything else you wish to say, Gavin.
No, I'm good.
Okay. So as I mentioned, let's casting a broad net right up front. What is he doing in this chapter? Okay, he's closing out this book by saying, there have historically been purported alternatives to evolution by natural selection as an explanation for complex design. Okay? What he wants to argue is that none of these purported explanations are actual explanations. They're not actual explanations, and therefore they're not actual alternatives to Darwinism. They're not alternatives to evolution by natural selection as a means of explaining complexity, complex design, such as the human eye. Okay? And the three sort of classes of rivals are Lamarckism, okay, and we'll talk about each in turn, which essentially gets at the inheritance of acquired characteristics, okay, and various versions of that. Another class of purported alternatives, but not actual alternatives, are mutationism, okay, and then finally, various versions of creationism. Okay, each one of these have been proposed as an alternative explanation for complexity, none of which have stood up the test of time. In fact, none of which have really provided any alternative to speak of, although some of those that proposed these purported alternatives thought that they were alternatives. So let's move then to talking. We'll talk first about Lamarckism. We'll follow the order in which Dawkins discusses these three classes of explanations. But I want to point out, which Dawkins does right at the beginning. He says, in this chapter, I shall take a different tack. Largely, this is top page 408 in my version. Largely because so many other books have examined the evidence and concluded in favor of Darwinism. I mean, I think it's safe to say, no, it is safe to say, it's accurate to say that all reputable biologists, all reputable biological scientists accept as fact, okay, that evolution by natural selection is the only known scientific cause of complexity. Okay? There are no reputable biologists who argue that there is some alternative, okay, explanation. Okay? It is literally accepted as fact, but not because that's what people want, but instead because that's what the data indicate over the past 160 years. Okay, so he's not going to take us through all the various, sort of machinations of, what's been proposed. Okay, instead he's going to examine the evidence, he says, for and against rival theories. Instead of examining the evidence for and against rival theories, he's going to adopt more of an armchair approach, he says. He says, my argument will be that Darwinism is the only known theory that is in principle capable of explaining certain aspects of life. Okay? He says, if I am right, it means that even if there were no actual evidence in favor of the Darwinian theory, there is, of course, he says, we should still be justified in preferring it over all rival theories. So what he's suggesting is that each of the purported alternatives can't even in principle explain complex design. He says the Darwinian theory is in principle capable of explaining life. No other theory that has ever been suggested is in principle capable of explaining life. It's a pretty strong statement. And he notes at the top, page 409, what are we really talking about here? What are we talking about when we talk about life? Okay, it can be complicated or it can be straightforward. And he keeps it very straightforward. And he argues that there's one particular property of living things, okay, that he wants to single out as explicable only by Darwinian selection. This property is the one that has been the recurring topic of this book, namely adaptive complexity. Okay. Then he goes on giving a couple of examples. He says here, living organisms are well fitted to survive and reproduce in their environments in ways too numerous and statistically improbable to have come about in a single chance blow. That's part of what we've been talking about. Following Paley, William Paley, and his Watchmaker example. Following Paley, I have used the example of the eye. Okay, 2 or 3 of an eye's well-designed features, okay, conceivably could have come about in a single lucky accident. It's the sheer number of interlocking parts, all well adapted to seeing and well adapted to each other, that demands a special kind of explanation beyond mere chance. The Darwinian explanation, of course, involves chance too, in the form of mutation, but the chance is filtered cumulatively by selection, step by step, over many generations. Other chapters have shown that this theory is capable of providing a satisfying explanation for adaptive complexity. Those are the previous chapters in this book. In this chapter, that is in the final chapter, Dawkins says, I shall argue that all other known theories are not capable of doing so. So he first tackles Lamarckism, okay? And there are basically two components to Lamarckism. Okay, this is the theory of that was presented before Darwin, and it was really the best that anyone had. And we should note that Darwin himself sort of tentatively conceded that, well, I guess it's okay. It can't be fully correct, but it's not just awful. Lamarck's theory had two components: the inheritance of acquired characteristics and the principle of use and disuse. I don't know, Gavin, do you want to take a swing at what is meant by the inheritance of acquired characteristics?
Sure. So focusing first on the acquired aspect, I think basically the idea that within the lifetime of a single organism, it can acquire some sort of characteristic. And typically, or the way I've heard it explained most often, is not that, it grows a horn out of nowhere, more so that it maybe builds a muscle or stretches like its neck, like in the giraffe is sort of the famous example that's typically used.
Right.
So that's what is meant by acquired characteristics, is that a single organism within its lifetime sort of develops or changes some physical aspect of itself in order to better survive in its environment, and then it passes on that acquired trait. So if a giraffe stretches its neck an inch longer than the rest of its than the rest of the population that it lives in, it'll pass on that longer neck to its children, and then over time, giraffes, by way of stretching their own necks within their own lifetimes, will gradually the population of giraffes will gradually come to have longer and longer necks on average.
Perfect. Yes, that is Lamarck's explanation for acquired characteristics, for acquiring characteristics that are then inherited by offspring. Now, how about the principle of use and disuse? How does that fit in with this?
So that's sort of similar. I believe it's sort of the other side to this coin. So if there is an animal who is using its leg muscles to run away from predators, then those leg muscles will gradually develop and get better. So that's part of the acquired characteristic aspect. But the other side of that is that if an animal is not using a certain muscle or a certain physical characteristic, then it will gradually shrink. It will, like a muscle that you don't use, it'll become weaker or atrophy to the point of non-existence. I assume if you follow it to its logical conclusion, it atrophies to the point of not existing anymore, depending on what trait you're talking about.
Right, yeah, and once again, that atrophy, then, the characteristic of let's say the atrophied muscle in an individual's lifetime, that atrophy is then passed on to offspring, okay? And so you can get a situation, according to Lamarck, this is how, animals that spend their lives in caves, sort of over time, according to Lamarck, through the disuse of eyes in, pitch black caves, okay, begin to produce offspring that flat out don't even have eyes, okay, because they're disused, they're not used, okay? Okay, so this was the best that was offered prior to Darwin, okay, and as I indicated, Darwin thought it had problems, and for various reasons. But the key problem with Lamarck's theories and his ideas is that there's simply no mechanism by which an acquired characteristic can be read back into the genome, okay, and then passed on to offspring. Okay, there's no mechanism of recording, okay, that acquisition, that acquired trait or characteristic, and then rewriting the genome to specify that acquired characteristic so that the offspring that's produced has that acquired characteristic. And that's a problem. There's no way to get the acquired characteristic back into the genes that produced the very trait that was then modified during the lifetime, okay? So that there's no way to pass it on, is the bottom line. There's no way to pass on the acquisition of learned or acquired characteristics. And so fundamentally, Lamarck's theory of the inheritance of acquired characteristics is wrong, okay, in the most important way. Namely, these acquired characteristics cannot be inherited, okay? So, there's not much more to be said for Lamarck's theories. Again, I think he's arguably unfairly maligned for coming up with a boneheaded theory. But the thing is, nobody knew about genes. Nobody knew about how inheritance occurred. We now know that it could not have occurred in the way that Lamarck was implying. And Darwin, and again, as I've mentioned a couple of times, and I'll just say even more specifically, Darwin did his best to find any value he could in Lamarck's theory. And he makes reference to Lamarck. He makes reference to the principle of use and disuse as a means of sort of modifying existing traits in a given individual's lifetime. The problem is they can't be passed on. And again, there's really nothing much more to say. There have been various attempts to reimagine Lamarckism. So for example, various sort of branches of, the term that's often used today is something called epigenetics. And this is often used incorrectly as a way of sort of arguing in favor of Lamarckism. Something about in the individual's lifetime changes the genetic code in such a way that an acquired or learned characteristic is somehow encoded into the genome and then passed on. Once again, there's simply no evidence for this. There is plenty of evidence that genes are turned on, and this can affect embryogenesis. But this is standard Darwinian evolution by natural selection. This is standard heritability. This is standard genetics. To call it epigenetics doesn't, to me, seem to add much. Given that what you're really doing is you're specifying that some genes affect other genes by being turned on or off. But again, that's standard genetics. There's nothing Lamarckian about it. Okay. Anything else you want to say about Lamarckism?
Do you think it's worth spending some time talking about the way in which use and disuse? I remember when I was reading The Origin of Species for the other class I co-instructed with you over the summer.
Yeah.
I believe that was Science and Superstition.
Yeah.
And reading Darwin's section on use and disuse, it felt like he was a little muddled, but then after we discussed it, I think it made a bit more sense. And I just wanted to say the way in which it might seem as though use and disuse plays some sort of role in the development of certain characteristics. Let's take, for instance, bats' eyes or moles' eyes. Animals that don't really use their eyes very much at all because they're in dark environments where they're not any use to them. The reason that their eyes work poorly, if they were to come above ground or if they were to come out during the day, the reason that their eyes work poorly is that natural selection hasn't been working on their eyes, so to speak, over the generations. So male mal-equipped, poorly functioning eyes were not removed from the population, and were able to, individuals with poor eyes, badly working eyes, were able to still reproduce and have children who inherited those poor eyes. And that is why you see animals who maybe haven't used their eyes in many generations have poor ones, not because of disuse, but because natural selection hasn't been working on it. And I just wanted to mention that.
Yeah, that's a really good point. And not only, yeah, and as a consequence of natural selection not working on it, various mutations and slips and goofs in the machinery that builds eyes are allowed to occur. And so, the eyes become malformed, they become, less finely tuned because natural selection can't see it. It's allowed to vary because it doesn't affect, the survival and reproductive success of the organisms, as you mentioned. So I think it's a very good point. The final thing I want to mention about Lamarckism is one of the key arguments that Lamarck made is that, the question is, well, one of the key arguments that he did make is that organisms strive, to improve. They're trying to improve. There's a sort of mysterious, life force that guides their efforts to improve, a particular adaptation or a particular trait. So giraffes aren't just happening to reach, to stretch to reach the taller, the leaves that are higher up. They're striving. They want to. They have, a guiding desire to improve their species. And here there's just that was, then as now, that was a rather mystical sort of argument that really seems superfluous at the time, according to many scientists, but it seems doubly so today. It's not clear because you're not really explaining anything. If you say, the reason that giraffes are trying to reach, the taller, they're striving to reach the taller leaves, in part because they want to stretch their necks, because they want to survive and reproduce, all of that mystical striving, itself then would need an explanation. Well, how in the world did the brain evolve such that it has these mechanisms that motivate the animal to strive, to reach, to strive to improve, the organism? It was just very unclear at the time, and I think it's much easier today to see how it was unclear. Again, it's any sort of striving to improve that notion requires complex machinery of the mind, okay? And therefore requires an explanation, how it got there. And that wasn't proposed. That explanation was not proposed by Lamarck, and it's sort of accepted as, well, there must be some way in which, animals strive. Lamarck was struggling for an explanation of why do animals do this? Why do they try to do this? Why do they appear to want to survive and want to improve, their species? And it was just, it was just a very cloudy sort of mystical notion. So at any rate, we can leave that for now. Should we leave Lamarckism?
Yeah, I'm good with that.
Okay, so let's talk then about see. I'm just finding my spot here. Okay, so he closes his discussion of Lamarckism. He says, this is on my version, page 431. He says, so it isn't that Lamarckism is a rival to the Darwinian theory that happens to be wrong. Lamarckism isn't a rival to Darwinism at all. Okay? It isn't even a serious candidate as an explanation for the evolution of adaptive complexity. It is doomed from the start as a potential rival. It just can't even get off the ground. Okay, most importantly, okay, because there's no mechanism for inheriting any acquired characteristics. You can't rewrite the genes that built the traits that then, in a lifetime, were improved. Okay. He goes on to say there are a few other theories that have been and even occasionally still are advanced as alternatives to Darwinian selection. Okay, and he says here, once again, I shall show that they are not really serious alternatives at all. I shall show, and he says in parentheses, it is really obvious that these, quote, alternatives, neutralism, mutationism, and so on, may or may not be responsible for some proportion of observed evolutionary change, okay? But they cannot be responsible for adaptive evolutionary change. That is, for change in the direction of building up improved devices for survival, like eyes, ears, elbow joints, and echo ranging devices. So we can start with either it's gone by different names, neutralism or mutationism. Let's just summarize a variety of these theories by focusing on mutationism. This is the argument that evolution is mostly the product of mutation. Okay. Now, there's no doubt that mutation plays an important role in evolution by natural selection. I mean, mutation provides the variation on which natural selection works in order to build, looking back, to build what we'll recognize as a human eye or an eagle eye or a bat's wing, for example. But mutations in and of themselves don't build anything. Okay, they are the variation on which natural selection works. I mean, the only way that mutations could explain the evolution of complexity is if mutations consistently occurred in a specific direction. Okay, in other words, a mutation in one generation, okay, would occur. Then in the next generation, another mutation in the correct direction and moving towards greater complexity occurred, and then so on. But all the evidence we have indicates that mutations are random. Okay, they're as likely to be lethal as they are to be improvements. Okay, any given mutation, genetic mutation, okay, in fact, on balance, is much more likely to be lethal, okay, than it is to improve the situation of a particular individual organism. And so that being the case, there's really, there's simply no evidence that mutations consistently and repeatedly occur in the direction of building up complex design. Okay, and that's a problem for mutationism. Okay, now, certainly mutationism is in some form is an important theory, and it's an important description of fact in evolutionary biology. But in that sense, mutationism, in a respectable sense, recognizes that most evolutionary change, okay, is due to mutation, okay? But evolutionary change is not the same as evolution that produces adaptive complexity, okay? There's variation, which is random with respect to which is random with respect to complexity, okay? And then there's variation that provides the grist for the mill of natural selection. So yes, genes in most species, mutate, okay? And that mutation, the mutations when they do occur aren't likely to be in one direction, that is increasing leg length or decreasing leg length, for example. They are random, okay? And there is no known pathway by which random mutation automatically produces complex design. Okay? And that's the trouble with mutationism as a purported alternative to evolution by natural selection, specifically with regard to the production of complex design, apparent design, like in the human eye. Does that make sense?
Oh, yeah. Yep. It's sort of feels like the other side of the coin to what Dawkins was arguing in a previous chapter. I think, yeah, Constructive Evolution, chapter 7, in which, he was
Yes.
sort of combating the argument that natural selection is only a reductive force and it can never add. So by in this section of chapter 11, what he's doing is, uh, to me, it kind of feels like reiterating the same point, which is that you really need both. Putting emphasis on any one side, any one aspect over the other is really sort of missing the mark, so to speak. That's the sense I got.
Yeah. Certainly looking for, an explanation for complex design in the fact of mutation. It's a doomed rival. There's no known process by which mutations will occur so that generation after generation, they automatically build up, complex designs like an eye. Unless you want to argue, of course, well, God is directing mutations. And you can do that, and people have done that. The problem then becomes, well, what explains God? I mean, you can't just declare by fiat that God exists. That God is likely to be as complex as any complex design you're attempting to explain with reference to God. Okay, and so therefore, you really haven't done any explanatory work, because now you painted yourself into a corner. Well, now you have to explain, where did God come from? And then to answer, that God has always been there. Okay, that's basically excusing yourself from any kind of rational discussion. So let me just spend just a couple more moments on mutation, because I think it is an important point. This is on page 434 of my version. Dawkins says, mutation is necessary for evolution. Okay, we know this. Mutation is necessary for evolution. But then he says, but how could anybody ever have thought it was sufficient? Evolutionary change is, to a far greater extent than chance alone would expect, improvement. Okay? The problem with mutation as the sole evolutionary force is simply stated. How on earth is mutation supposed to, quote, know what will be good for the animal and what will not? Of all possible changes that might occur to an existing complex mechanism like an organ, the vast majority will make it worse. Only a tiny minority of changes will make it better. Anybody who wants to argue that mutation without selection is the driving force of evolution must explain how it comes about that mutations tend to be for the better. I mean, that seems pretty straightforward when it's laid out so plainly. Now, this then leads us, if we accept that mutationism, while explaining genetic variation, can't explain complexity. You can't just, there's no rule that says all mutation must result in improvements. And in fact, the data indicate that the vast majority of mutations are bad. Okay?
Right.
So this leads to his discussion of the final potential alternative, or at least one of these alternatives. Let's see. Let's see. Okay. He says, this is towards the end of page 450. He says, we've dealt with all of the alleged alternatives to the theory of natural selection, except the oldest one. Okay, this is the theory that life was created or its evolution masterminded by a conscious designer. Okay, it would obviously be unfairly easy to demolish some particular version of this theory, such as the one, or maybe two, spelled out in Genesis. Nearly all peoples have developed their own creation myth, okay, and the Genesis story is just the one that happened to have been adopted by one particular tribe of Middle Eastern herders. Okay? It has no more special status than the belief of a particular West African tribe that the world was created from the excrement of ants. Okay? And as you can imagine, there are thousands and thousands of such creation stories. Okay, there was once a time on Earth where most people believed, in the world having been created by any one of the Greek gods, for example. Okay, all these myths have in common that they depend upon the deliberate intentions of some kind of supernatural being. Okay, let's see. So he notes that we cannot disprove beliefs like these, especially if it is assumed that God took care that his interventions always closely mimicked what would be expected from evolution by natural selection. All that we can say about such beliefs is, firstly, that they are superfluous, that is, that they don't add anything to our explanation, and secondly, that they assume the existence of the main thing we want to explain, namely organized complexity, okay, in the form of God or gods or supernatural agents, which have to be at least as complex as the very designs that they're purported to have poofed into existence. He says the one thing that makes evolution, that is evolution by natural selection, such a neat theory is that it explains how organized complexity can arise out of primeval simplicity. Okay, bit by bit by bit, over the course of vast expanses of geological time. Let's see. There's a couple of, let's see, he says, if we want to postulate a deity, a god, capable of engineering all the organized complexity in the world, either instantaneously or by guiding evolution, either one of those, that deity must already have been vastly complex in the first place. The creationist, whether a naive Bible thumper or an educated bishop, simply postulates an already existing being of prodigious intelligence and complexity. Then Dawkins says, if we are going to allow ourselves the luxury of postulating organized complexity without offering an explanation, we might as well make a job of it and simply postulate the existence of life as we know it. Okay, he goes on to say, the theory of evolution by cumulative natural selection is the only theory we know of that is in principle capable of explaining the existence of organized complexity. Even if the evidence did not favor it, which it most certainly does, it would still be the best theory available. In fact, the evidence does favor it, but that is another story. And I don't know what more can be said about the design theory or the theory of special creation. I mean, special creation by a god was precisely the theory that Darwin was arguing against. Okay? And there are multiple versions of, the design theory, some wonderfully complicated, and certainly much more complicated than the special creation theory that Darwin was arguing against, when he wrote his book 150 or 160 years ago. But none of them, or I should say all of them, paint themselves into a corner of having to explain where this supernatural entity or deity or God or spirit or agent came from. Okay? And in every case, the argument is simply, well, it's God, or it's always been there. There's no effort to explain the evolution of God itself. But that's just it. I mean, if it's a, if it's a theory that's a religious theory, it's accepted on the face of it, and there's no apparent need to explain the evolution of that God. But that's the problem, is that you're basically invoking by declaration or by fiat, an entity that is at least as complex as the very complexity you're trying to explain. And so you really haven't explained anything. You've just renamed it.
Right. No, I agree. It's always difficult to I feel to grapple with creationist explanations. It's almost like not, if you're just going to ultimately conclude or arrive at a creationist explanation, it's almost not worth going through the trouble of fighting with all the other explanations that require some sort of linear logic or whatever, because the creationist explanation just sort of regardless of where you want to stop or
Right.
where you want to focus on, you still have to build in those assumptions or the main assumption of a creator. So
Right. And it's devastating. It's devastating for a scientific explanation to simply declare by fiat or by virtue of a holy book that a creator exists. I mean, there's no place for that in science. I mean, you can imagine how quickly that would devolve. I mean, you'd have, and our students must recognize that there are thousands of gods. Okay, yes, if you just paint with broad brushstrokes, there are the Abrahamic gods. Okay, the gods of Christianity and Islam, okay, and Judaism. But you must realize that there are 8 billion people in the world, okay, and only something around 4 billion are Christian or Muslim or Jewish. There are hundreds and hundreds and hundreds of other religions, okay, which, for example, invoke, various other gods. Why? Because that's what they were taught. Because that's what their holy book says, or that's what their parents taught them. So you find yourself having no way to determine which one is the right God. And ultimately, no way to verify, no way to test, which means it's not a good, it's not a scientific explanation for evolution, for evolution by natural selection. It's not a scientific explanation for design complexity, because ultimately you paint yourself into a corner which says, and you find yourself having to say, well, that's what the Bible says. It says it right there in the Bible. But then, of course, the person you're talking with, what if they don't accept that the Bible is the one true word of God? Well, then they're not going to put any weight in it. Okay, that's your God is not going to be their God. And then the conversation is over. I don't mean to suggest that there aren't, and I think I did suggest that there are far more complicated, theories of special design. And there are biologists who recognize the fact of evolution by natural selection, but they're also religious. And what they argue is that, well, God placed the first, glimmers of light, or the first self-replicating element on Earth, and then occasionally guides evolution. The problem there is, once again, you paint yourself into a corner of ultimately having to claim that, well, I know that this God is there because that's what the Holy Book says, or that's what my priest says, or that's what, all Catholics believe, or whatever the particular religion is. And once again, that's superfluous. It doesn't add anything. It doesn't add anything that can't otherwise potentially be explained without reference to an unverifiable supernatural agent.
Right. Yeah. It's just moving the problem back, essentially.
Yeah, that's exactly right. It's moving the problem back, and I see no way around it. But I do want to recognize that there are, very smart people. There's an evolutionary biologist of all, named Ken Miller, who's an evolutionary biologist at Brown University. I mean, he's a wonderful scholar, but he's also a practicing Catholic, and he sees no conflict in the fact of evolution by natural selection and his Catholic beliefs. What he does is he simply pushes the problem back, and he says, well, God created the universe, see, and then God also seeded life and occasionally guides things. But otherwise, evolution proceeds just exactly as Darwin described it, evolution by natural selection. It's just that I can't see that adds anything to how we understand life and the evolution of complex design. All it really does is add something to the mix that we now have to explain. Well, where did the Abrahamic God come from? And Ken Miller's retort is, as explained, in the holy books, God has always been there, always. And so he's basically saying, well, I don't want to play. I don't have to offer an explanation. But that's asking quite a lot of your, of the people you're attempting to have a discussion with, who may or may not be Catholic.
Right.
So there you have it. I don't know. Is there anything further we want to say about the design theory?
No, I'm tapped personally.
Yeah. Okay. So that then concludes our discussion of the Blind Watchmaker. I don't know that there's anything further. Let me just take a peek at the last few pages here. I don't think so. I think we've covered, those are the three major classes of alternatives. I mean, one could argue that there might be two or three other classes, but the bottom line is none of them yet are even in principle. By yet, I mean maybe someone will do a better job than has been done so far, but none of the purported alternatives to evolution by natural selection, alternative explanations for complex design, none of those purported alternatives have even, grown up to the point at which they could possibly explain, complex design. Never mind have generated, sufficient evidence, data, to be worth questioning the likely, truth value of evolution by natural selection as the cause of complex design. Okay, so next time then we will pick up and begin talking about the goodness paradox by Richard Wrangham. So basically we'll take a lot of these sort of more abstract and theoretical ideas and we'll start applying them directly to humans and non-human primates, and even more directly to the issue of violence and aggression on the one hand, and cooperation and kindness on the other hand. So we'll start applying evolutionary principles and ideas to human and non-human psychology and behavior.
Yeah, and I think, like you just said, it'll be important not only to make sure that you, and this speaking to the students, that you guys have a really clear idea of natural selection, but also that you're able to apply those concepts, like you said, some of the more abstract stuff we've read so far, to human behavior and psychology, and just to keep in mind that natural selection works on animal behavior and the psychology, the cognitive machinery that is responsible for that animal behavior, just as it does physical traits. So, just be careful not to get too hung up on that, because that'll be a lot of the next book that we read.
That's a good point. And I mean, there will be many occasions where Gavin and I will presume that you have lingering questions about evolution by natural selection, and that's perfectly fine. I mean, to bring them up. I mean, what you will find is that Wrangham does not. We're not going to start over. Wrangham does not, spend any length of time discussing the principle of evolution by natural selection or mutationism, or he doesn't get into a lot of these, a lot of what we've just discussed. He presumes, for the most part, that you have a generally good understanding of, evolution by natural selection. That was the point of having you read Dawkins first, so that you will have a firm foundation now that can be applied to human and non-human primate psychology and behavior.
Right.
Okay. All right, very good then. So please do see that final episode, episode 5 from the PBS Evolution series. I think you'll appreciate it, and I think it does, if nothing else, will bring to light that there are other ways to reproduce besides sexually. And given the problems and given all the baggage of sexual reproduction, I think it is a legitimate question to ask, why in the world do organisms reproduce sexually when it would be so much easier just to clone oneself? There are very good reasons for that, and that's part of what you'll learn about in that episode 5 from the PBS Evolution series. So we will see you again then next week.